Okay, so today we are going to learn about quadratic inequality in one variable. Last class was about two variables because it had x and y, and they're two different variables. Now we'll just have only one variable, which is x. Okay, and in two variables we compared our value with y. Since we don't have a second variable, we are going to compare our value to 0, not a y variable. Okay, so you guys attempted to do this question and you guys said that this would be a possible parabola, which works, but this is not a function, right? Because if I look at this, it passes through two different points. So we would still think of it as a parabola, but we won't consider it as a function. Okay, so let's look at some examples of what a parabola could look like when the function is less than 0. So our parabola is given to you. You would want your x to be less than 0, right? Now consider this is y is equal to 0, right? Your x-axis is y is equal to 0. We want everything in this function to be less than 0. So we'll just shade this portion right here, okay? We won't include these because it doesn't say it's equal to, okay? Now when it says it's equal to, we would shade the same region because it's less than, so below, and we'll put full circles over here. Do you guys remember in grade 9 when you guys were given inequalities and it said, let's say this is 0, 1, 2, 3, 4, negative 1, 4. And if it said x is less than 3, you would put this sign and then you'll draw an arrow over here going that way, right? And if it said x is less than equal to 3, you would draw a colored circle or a filled in circle and depict it like that. So when you have an equal to, just like how you did over here, you would have a filled in circle, because then these points where y is equal to 0 are also part of the solution. However, over here, they're not part of the solution. Okay, let's do the next one. Try it yourself. It's greater than, so above. And will it be open circled or closed circled? Open, because it's not equal to again. Okay, it says equal to now, so it'll be these. Okay, are the zeros x-intercepts included? Again, remember from quadratic functions, zeros are x-intercepts or solution. Are they included too? In this case, no, they are not, right? Because they're open circle and it's not equal to. Yes, because there's an equal to sign. No, because there's an equal to sign doesn't exist. Yes, because there is an equal to sign. Okay, so this is the catch over here. We are not looking at solid lines or dotted lines or dashed lines, broken lines. We're looking at dots. Are they filled in or are they empty? Okay, let's do a few examples over here. Solve a one variable quadratic inequality using algebra and graphically. So an equation is given to you, it's less than equal to 0. Now you ask yourself, first thing, is this a one variable or two variable? It's a one variable because x is the only thing that's given to you. If you're doing this using by sketching, we would want to convert the standard equation into a vertex form and a factored form, because that way it'll be easy for us to find the vertex and the x-intercepts. So let's convert this into vertex form. When I have vertex form, whatever I have in the middle, our b value, I'm going to divide it by 2. Let's write it more neatly. X squared minus 2x minus 3 this will be divided by 2. You get -1, and then you square it. -1 square is 1. So you are going to add 1 and subtract 1. The rest of the things will be the same. Okay. Now you'll take this part of the solution and you'll write x minus 1 squared. -1 minus 3 is -4. This is from quadratic equation, you guys, completing the square, right? And that's less than equal to 0. Okay, so my p and q values will be 1 and -4. 1 and -4 is right here. Now I'm going to make this standard form into factored form as well. So my product is -3, my sum is -2, and my factors are -3 and 1. So it'll be x minus 3 and x plus 1 is less than equal to 0. So x is 3 and -1. So those will be my points. It'll be 3, 0 and -1, 0. This helps me figure out my x-intercepts. Okay, so 3 and -1. Okay, you could also find your x values like this step instead of converting it into factored form. You could use quadratic formula as well. I find this to be easier because I can figure out my factors. But if you think you have a hard time figuring out the factors, you can use quadratic formula. I would recommend that you try using this so that you can practice using factored form and finding factors. So try relying on this, you guys. But if, again, you cannot find factors, use quadratic formula. Okay, so my parabola is going to look like this. Okay, now it says it's less than equal to. Will I draw, like when you had two variable, right, you ask yourself, is it solid or dashed, right? And then you ask yourself, is it above or below? For this question, you guys, you're still going to ask this question above or below, but instead of this, you're going, because it's one variable, you're going to say, should I draw a full circle or an empty one? Okay, so in this case, because it's an equal to, I'm going to draw full circles. They're already full, right? And then it's less than. So in this case, whatever my function is, I need to look at my function and not this. Okay, so my function needs to be less than, that means it's below. So this is what my solution will be. When you did two variable questions, you guys, you looked at y is less than or not. And then if it was less than, you drew below. In this case, we are going to look at, for one variable, we are going to look at if whatever our function is, right, whatever our function is, if it's less than or greater than. Okay, let's do the same thing using algebra now. Pay close attention to this, you guys. So we are given the equation. We need to find our zeros over here, right? We need to find our x values and we need to write our solution. So for zeros, we'll just do the same thing as we did for factored form. So you had x minus 3 and x plus 1 is less than equal to 0, where x is 3 and -1. So I'm going to draw a number line now to figure out what all is included in my solution. So I'm going to go from 4, 3, 2, 1, 0, -1, -2, -3, and -4. Now, clearly, because it's an equal to sign, my 3 is being included and my -1 is being included. And everything in between that is also included. Okay? That means my solution is going to be x such that is between -1, x is greater than equal to -1 and less than equal to 3 xer, and you can also write it as -1 comma 3. Remember, you'll use square brackets because the solution 3 and -1 are included in the solution. Now, before I'm done with everything, I need to make sure and verify using test points. Okay, so my test point over here, let's say x is equal to -2. I'm going to use that. I'm going to use x is equal to 0 for that one. Let's put this into my original equation. Always put your test points in the original equation, you guys. So -2 squared minus 2 times -2 minus 3. And it should be less than equal to 0. So let's see that. So -2 squared is 4 plus -2 times -2 is positive 4 minus 3 is less than equal to 0. Just gonna move this. Okay, 4 plus 4 is 8. 8 minus 3 is 5. Is 5 less than 0? No, that means this shouldn't be part of the solution. Okay, let's take 0 now. So 0 is, we'll put it back in the original equation. So 0 squared minus 2 times 0 minus 3 less than equal to 0. 0 minus 0 is 0. Minus 3 is minus 3. Is this true? Yes, it is. Minus 3 is less than 0. So it will be part of my solution. Let's take 4 now. 4 squared minus 2 times 4 minus 3 should be less than equal to 0. 4 squared is 16, minus 2 times 4 is 8, should be less than 0. So 16 minus 8 is 8, 8 minus 3 is 5. Is 5 less than 0? No, it is not. So it's not part of the solution. The only thing that's part of our solution is this. Okay, where 3 and -1 are also part of it. Okay, that's it. Okay, now they've given us the same function as we had over here, and they're asking us, they've changed the sign to greater than in 0. So will it be a full circle or empty circle? Empty circle, because we don't have an equal to sign, right? Will it be shaded above or below? Because we're looking at our x, it's going to be above, right? So it'll be the same graph as we had over here. Let's just graph it. So it's -1 and 3. And the vertex was somewhere over here. It's just a rough graph over here, you guys. Because it's empty, I'll draw empty circles over here. And then I'll shade this region. Okay. And then set interval and interval notation. So set is when you're using your curly brackets. So x such that x is greater than, is less than -1 because we're going that way, right? And it is greater than 3 because we're going that way. XER, and your interval notation, don't mix these up. Interval notation will be your round brackets, right? And it'll be -infinity to -1. Union is and, union is or. 3 and positive infinity. If you struggle with these type of things, just remember that if we are going, like, draw these arrows, okay? I'm going from 3 to positive infinity. I'm going -1 to -infinity, okay? Okay, and that's it. So the steps for this one, like the first step, if you don't want to remember the steps, all you need to do is go back to the question and they're asking you for the solution in the set. That means you need to find your x values, right? move all the terms to one set, find your x values, right? Using factor form or quadratic formula. That's the two way we find our x value. And then you need to figure out your interval. To figure out my interval or my solution, I draw a number line to see which points are part of the solution and which are not. And then I write the solution based on the ones that are part of it. Okay. I look at the square bracket or round bracket. If it's an equal to, it'll be squared. If it's not equal to, it'll be round. Okay. And those are the 5 steps, you guys. Okay. I would recommend you guys to pause this video and then we'll discuss the solution. So they have given us this equation. I'll ask myself, is it 1 variable, 2 variable? 1 variable. Okay. Will this be closed circle or open circle? Closed, right? Because there is an equal to sign. Will it be above or below? Well, it's less than, so it's going to be below, right? Now I solve this. They've said use algebra to solve this. So I have 3x squared plus 10x minus 8. You can use quadratic formula if you want. I'm going to do it using factored form. So I'll look at, or product sum factored, right? So product is 3 times negative 8, which is negative 24. Sum is 10. Your factors will be 12 and minus 2. So it'll be 3x squared plus 12x minus 2x minus 8. Factor the 3, you get x squared plus 4. Factor the negative 2 from these two terms, you get factor 3x out from the first one, you get x plus 4. Factor 4 plus x plus 4 on this term and you get 3x minus 2, and then you're left with x is equal to negative 4 and 2 over 3. Okay, remember we just reverse the sign, reverse and divide. Okay, so these are my 2 critical points that I'm looking at. Now I'll graph it. So on the number line, 2 over 3 approximately is 0.6. Okay, so I have 3, 2, 1, 0. 0.6 will be somewhere over here, and it's because it's equal to, I'm going to draw a solid circle over here. 1, negative 1, negative 2, negative 3, negative 4, negative 5. Close circle here too. I'm going to take my test points now. So let's take negative 5 over here. X is equal to negative 5. Put it in the original function. So you have 3 times negative 5 squared plus 10 times minus 5 minus 8. That should be less than equal to 0. Put that in. So 3 times negative 5 squared is 3 times 25, which is 75. 10 times minus 5 is negative 50 minus 8. 75 minus 50 is 25. 25 minus 8 is 17. 17 is less than equal to 0. Is that true? Not true. That means that's not part of my solution. Now I'll take a point from here. Oh, so zero. Let's take 0 because that's always easy. Anything multiplied by 0 is 0. So 3 0 squared plus 10 times 0 minus 8 should be less than equal to 0. 0 plus 0 minus 8. Minus 8 is less than equal to 0. Is that true? Yes, it is. Awesome. Now, let's take 1. 1 is also easy because 1 squared is 1. So 3 times 1 squared plus 10 times 1 minus 8 should be less than equal to 0. 3 times 1 is 3. 10 times 1 is 10 minus 8. 13 minus 8 is 5. Is 5 less than 0? No, it's not part of the solution. So now I'm going to write my solution in the set interval form, set form. So it'll be x such that we have -4, all the values of x, including -4. So till 2/3 XER. You can also say -4 comma 2/3. Okay. Okay, guys, that's it. Now remember, this is your solution and you will only have x as your solution. You won't have y as your solution because y is not part of the equation. Okay, only have one variable. Let's do the next one. Solve using algebra. This is given to you. Now this is not on one side of the equation, so I'll have to move everything to the other side. Subtract x, subtract 12 on both sides. You get 0 less than, because x minus x is 0, 12 minus 12 is 0, x squared minus x minus 12. So I can do product is -12, sum is -1. Factors will be -4 comma 3. So it'll be x minus 4 times x plus 3. Now the reason why I just plugged in whatever the factors were because the coefficient is 1. In the question above, the coefficient was 3. That's why I did not directly plug them in. Okay. So, so that means x is equal to 4 and it's -3, just reversing the signs. Okay. Now I need to draw my number line to figure out what is part of the solution and what isn't. So let's do -4 here, -3, -2, -1, 0, 1, 2, 3, 4, and then 5 over here. Okay. Now, is this a solid circle or an empty circle? Empty because there's no equal to. Okay, so we have -3 and 4 empty circles. Okay, draw the line so that I can figure out what's part of the solution and what's not. Let's take -4, x is equal to -4. Plug that in my original equation. So -4 plus 12 is less than -4 squared. -4 squared is 16. -4 plus 12 is 8. Is that true? Is 8 less than 16? Yes, it is. So that's part of the solution. Let's look at this. So let's take 0, easy, right? 0 plus 12 less than 0 squared. 12 is less than 0. Is that true? No, it's not. Not part of the solution. Let's take 5. So we have 5 plus 17 is less than 5 squared. 17 is less than 25. Is that true? Yes, it is. That means our solution will be -infinity to -3 and 4 to +infinity. Okay, to write this down in set interval form, it will be x such that x is less than -3, or it is x is greater than 4, XER, and in interval notation you'll write -infinity comma infinity or 4 comma +infinity. Okay, so that's why always testing, like when you're solving using algebra, you need to test it using your test points from 1, 2, and 3. Will it be part of the parabola or not? So if I were to roughly graphically draw this, it'll be -3 over here, 4 over here, and then we're just going like that. That's just my assumption. I don't know what my x-intercept is, or I can say it's -12, right? So let's say this is -12. Okay, so because it is using graphically method, this would be open circles, right? And then because x is above or is greater than 0, right, all this is greater than, so it will be this stuff right here. Okay, awesome. Now let's do some application questions for the same. If a baseball is thrown at an initial speed of 15 meters per second from a height of 2 meters above the ground, the inequality this models the time that the baseball is in flight. T is the time of the flight measured in second. Graphically determine during what time interval is the baseball in flight. Give the solution in set or notation form. So graphically, right? Now, I know that the ball is, the seconds are over here. T is your seconds and H is your height. So this will be my height in meters and time in seconds. Okay, this is my 0. And you know your C value is 2. So over here, it's starting at 2 as well. You guys know that because 2 meters, right? And its initial speed is 15 meters per second, right? So it'll be like that, right? You could convert this using a factored form or vertex, or completing the square or product sum factor, but I'm just going to use a calculator. So y is equal to, I'm just plugging the equation, 4.9x squared plus 15x plus 2 in graph it. This is what it looks like. I'm going to change my window setting here. I'm going to say x is 30 and then y is 30 as well. Actually, x just can be 10. Let's graph it. Okay, now I need to find out how long it is in flight, right? So we're starting at 2, right? 2 as our height. And then because I need to figure out the time it is in flight, I need to figure out what this point is. Now, what is this called, you guys? X-intercept. So I can do second trace 2 because x-intercept is 0 as well, right? So this is my left bound, this is my right, and this is my guess, and it's at 3.19. Okay, x is equal to 3.189, so I can just round it up. And at height 2 meters, it is at 0 seconds. So we're starting at 0 seconds. That means it's from 0 to 3.2. Because it's between 0 to 3.2, at 3.2, it's going to be on the ground, right? So we'll say 0 less than, we're not going to include our 0, and we're not going to include our 3.2, XER. That's our set notation. Our interval notation is 0, 3.2. Again, round brackets, we're not including it. Okay. I want you guys to pause the video and try the next question. Solve this using algebra. You want to figure out the exact value. I hope by now you guys know what exact values are. Radical form, we don't want our decimals, and it needs to be simplified. And then approximately value to the nearest 100. So this means figure out the decimal as well. So they want both of us from us. We need to figure out this using algebra. So let's move everything to one side. Minus 12. Because I'm just subtracting 12 on both sides. Now, it said quadratic formula, right? So A is 2, B is -7, and C is -12. X is equal to minus B which is negative 7, plus minus b squared, which is 7 squared, minus 4a, which is 2, and b, which is, sorry, 4ac, which is negative 12. Right, quadratic formula is just minus b plus minus b squared minus 4ac over 2a. So 2 times a, which is 2. Now, the reason why we are using quadratic formula, you guys, is because if I think of my product, negative 12 times 2 is negative 24. My sum is negative 7. Are there any factors that can make it possible? Well, the factors of 24 are 24, 1, 12, 2, 4, 6, 8, 3. And that's it, right? So none of them add or subtract to B7. So I'm going to just stick to this. Negative times negative is positive 7. Denominator 2 times 2 is 4. Negative 7 squared is 49. Minus 4 times 2 is 8 times 12 is, times negative 12 is negative 96. Or you can just plug all this in the calculator as well. But I wanted to show it to you guys because I did notice that you had a tough time when you had negative over here and here. Well, it's just multiplying, right? So negative times negative is just going to be positive. So 7 plus minus 49 plus 96 is 145 over 4. Now, I need to figure out if it can be reduced into a radical or not. In this case, I can look at my perfect squares. I can divide 145 by 4. Doesn't work. 145 by 9. Doesn't work. 25 and so on. When you divide by a perfect square and you figure out it's not gonna work, this is its simplified exact value. Okay, now in decimal form you'll have to do plus and minus. So I mean you'll have to do plus and minus. When you do that and you put it in the calculator, you'll get 4.76 and negative 1.26. Okay, but we're not done yet. We need to figure out our solution, right? And because it's greater than equal to, both these things will be included in the solution. I'm just going to erase this. And I'm going to say x such that x is less than equal to negative 1.26 or x is greater than equal to 4.76 XER. Okay, or you can say negative infinity to negative 2.6 or 4.76 positive infinity. Now, of course, to figure out if it's or like if it's less than or greater than, you'll have to draw a number line. You'll have to do negative 1.26 and then up till 4.67. Sorry, 76. I'm so used to 6.7 now. And then you'll have to figure out 5 over here. This would be one of your test points. This 0 will be one of your test points. Negative 2 can be one of your test points. And then when you plug it in the actual equation, this will be part of the solution, this won't be, and this will be. Okay, so just going to write down the steps. Step 1, find the x values. Step 2, draw the number line. Step 3, test the test points. Step 4, make the equation. Okay, I mean the obvious step over here was like when you make the number line, make sure you write the critical points over here, the negative, like the x values, then test the points, and then write it as your solution. Again, this won't have a y solution because we don't have a y variable. However, when you look at your previous lesson, when we had two variables, you'll have both x and y points included in the shaded region, right? Like you 2,1 will be a point, so the y value over here will be 1, right? So just remember that. Okay, just to recap, when we're doing it graphically, you need to ask yourself, will it be open circle or closed circle? Am I going to shade the solution above or below the x-axis? And then you're going to ask yourself, and before you do that, make sure your graph is correct in case it's on the non-calculator portion of the test. Second thing, when it comes to algebra, there are 5 steps. You figure out your x value. You can do that by factored form, by finding factors, product sum factors. You can do it by quadratic formula. Those are the 2 things you can use to do it using algebra. You cannot use vertex form because vertex form doesn't give you your x value. After you're done with your x values, you draw a number line, you put your critical points, i.e. your x-intercepts on the number line. You divide it into 3 regions. You take 1 test point each from all these regions and figure out which region is part of the solution or not. And then you're supposed to write it in set interval or set notation or interval notation. And that's it.